It's a beautiful day. I decided to do this outside, so it may be a little noisy. We're going to look at homogeneous equations. They're basically, it's more of a detailed development of the separable equations. So basically, we've been looking at differential equations of this form, and specifically an equation is considered homogeneous if it can be written in this form: y over x, or let's say conversely x over y. And in this case, if it can be written as y over x, we substitute a variable, v equals y of x, or x v equals y, jumping ahead, y. So if we want dy dx, we got dy dx is equal to x dv dx plus v. And so with that, we have x dv dx minus v is equal to f of v. And doing a little algebra, we have x dv dx is equal to f of v plus v. I'm sorry, this is minus, and got to get the signs right, minus v. And a little more algebra, we got dv over f of v minus v is equal to dx over x. And basically that's the extent of homogeneous equations. Any equation that can be written in this form is homogeneous. So, with that, let's take a look at an example. We'll take a look at an example. An explicit example that was given to us: dy dx is equal to y squared plus 2xy over x squared. So we can separate this out. We've got y over x squared plus 2y over x, just simple algebra. Now, knowing that y over x is v, boy, sometimes I talk and I get distracted. All right, so we have that variable, so we go dx dv dx plus v equals v squared plus 2v. Now, a little more algebra. dv dx is equal to v squared plus v. And we bring this over. dv on v plus 1 equals dx over x. Now we have to solve this differential equation, and we can do so by partial fractions. So we say a over v plus b over v plus 1 is equal to 1 over v plus 1. Multiply across by that denominator, we got a times v plus 1 plus b v equals 1. Now if we choose v equals 0, we got a equals 1. So in that case, if we have that, we end up with v plus 1 plus bv equals 1. If we choose v equals 1, we have 2 plus b equals 1. b then is equal to minus 1. Now we could always check that to make sure that we're right. So we got, we got 1 over v plus minus 1 over v plus 1 is equal to v plus 1 minus v on v times v plus 1, and that's our answer. So that works. So we now have the differential equation of dv over v minus dv over v plus 1 is equal to dx over x. Now if we do the integrations, we have a simple integration. We got ln v minus ln v plus 1 equals ln x plus c. And a little logarithmic math. We have ln v on v plus 1 is equal to ln x, and that would be our equation. And if we then raised it all to an exponential, take this e to the ln v, we would have v on v plus 1 is equal to e to the ln x times e to the c, and that would be c e to the ln x, and then we got cx equals v over v plus 1. Now we know that v is equal to y over x, so we have y over x and y over x plus 1 is equal to cx. Now we're running out of space here, so let's get a new sheet. Oops, darn it. Alright, so again we have v on v plus 1 is equal to x. We could say we got c over here if we want. And then we got v plus c equals x times v plus 1, v plus c equals x times y on x plus 1, and that is y plus x, and y on x plus c, and y on x minus y equals x plus c. Again, c is very arbitrary. So we have y times 1 on x minus 1 equals x plus c. And we got y times 1 minus x over x equals x plus c. Y equals x squared over 1 minus x plus cx which is basically another constant, x squared on 1 minus x plus c. So that's essentially the solution to this problem. You can see how the method works, and there's some pretty interesting problems, complex problems that we can solve with this methodology. Homogeneity, property of homogeneity. So let's look at some of these. One I worked on yesterday was quite involved. It was an interesting problem, and I wasn't going to give up on it. It's the 4th of July, and the boats are out on the lake in full force, firecrackers going, people having cookouts. We had ours yesterday. It just so happens to be my grandson's birthday about a week ago, so we had a little birthday celebration. All right, so here's our next problem. We then have 1 plus y on x, so we have dv x dv dx plus v equals 1 plus v. So we got x dv dx equals 1. dv equals dx over x, and v plus c equals ln x. And now I guess we can leave it at this. We got v equals ln x plus c, or minus c. It really doesn't matter, does it? Thought I had it on the eraser. Okay. Minus c. Oh, oops. I wrote x. Gotta pay attention. So we got y on x equals ln x minus c. Y equals x ln x minus cx. And it really doesn't matter if we simplify it any further. We can leave it in this form. So we'll just box it. And that was simple enough. Let's take a look at another example. There are probably 5 or 6 examples I'm going to provide. Here we have 2y dx minus x dy equals 0. 2y minus x dy dx equals 0. And if we divide by x throughout, we've got 2y on x minus dy dx equals 0. This means dy dx equals 2y on x. And now we convert dv dx plus v equals 2v. And we have dv dx equals x equals v. dv on v equals dx on x. Ln v equals ln x plus c. Or we could have it the other way around. We could put the c on this side. Raise it all to the power, exponential. So we got e to the v times e to the c equals e to the ln x. That's c. Ln v equals, whoops, I made a careless mistake here. Alright, let's do this right. E. Now this is e to the ln v, e to the c equals e to the ln x, and that's c, not ln, but v equals x. And we can always bring the c to the x on the other side. So let's see, we got c y on x equals x. Let's bring this up here, and we've got y equals cx squared. And that is our solution. That was a simple one. Although I was being a little hasty. And when I'm hasty, sometimes I'm a little careless with simple things. Okay, so let's take a look at another one before the sun starts heating this thing up. dy dx equals x squared plus xy plus y squared on x squared, which is equal to 1 plus y on x plus y on x squared. Convert x dv dx is equal to 1 plus v is 1 plus v plus v squared. Okay, so these cancel. We got dv on v squared plus 1 equals dx on x. So in this we can use a trig substitution. So we got v squared plus 1. So let's say v equals tangent theta dv equals secant squared theta d theta. So secant squared theta d theta on tangent squared theta plus 1, but we know that tangent squared theta plus 1 is equal to secant squared theta. Just an identity. So this is equal to dx on x. So we end up with d theta equals dx on x. And theta equals ln x plus c. And arctan of v equals theta. So we have arctan of v equals ln x plus c. And then we have arc tan of y on x equals ln x plus c. And that's, well, we could always bring ln x over, and we got arctan of y on x minus ln x equals a constant, and that could be our solution to this homogeneous differential equation. Nice thing about that one is that it could be done on a single pane or sheet using Adobe Sketch. If you haven't guessed by now, it saves you from having to see me, which really doesn't matter, because the most important thing is seeing how these problems are solved. And some of them are pretty interesting. And they do have practical applications, which we will get to soon. And then we'll get to second-order differential equations, which is a major goal for me. And we're going to take a look at other solutions like infinite series solutions and other things that can be very, very fascinating. Infinite series are really cool. dy dx is equal to, now let's separate this out. We got 1/2, let's do it this way, 1/2 of x on y plus 3, and this is going to be y on x. And then we see that this is all 1/2 of 1 on y on x plus 3 y on x. And then we convert, we got x dv dx plus v equal to 1/2 1 on v plus 3/2 v. And so now we bring the v over. We got dv dx is equal to 1/2 1 on v plus, and that's minus v, so we got 1/2 v. And now we've got dv over, that's 2, and we got 1 on v plus v equals dx on x, and this then is v dv on v squared plus 1. And times 2 equals dx on x. So now we've got this ratio. Let's do partial fractions. We got a on v plus 1 plus b on, did I do it that way? Did I do partial fractions? I could have, but I don't know if I did that or not. Let's try it. V plus 1 equals 1 on v squared plus 1. No, I didn't. What am I doing? I didn't do it that. That's complete garbage, sorry. What I did was this. I said v equals tangent theta dv equals secant squared theta d theta, and we ended up with this 2 tangent theta secant squared theta d theta over tangent squared theta plus 1 equals dx on x. And it looks like we're going to need another sheet to do this. So let's, it's starting to get too bright to be able to see what I'm doing here. I might be able to pull this back a little bit. All right, a little more out of the sun. Okay, so we had 2 tangent theta secant squared theta d theta on tangent squared theta plus 1 equals dx on x, and we had v equals tangent theta and dv equals secant squared theta d theta, just for reference. And then we know that tangent squared theta plus 1 is secant squared theta. So those terms go out, and we're left with 2 tan theta d theta equals dx on x. But remembering what tangent is, and we say u equals cosine theta, du equals minus sine theta d theta. So we end up with minus 2 du on u equals dx on x. And we have 2 ln u equals ln x. And now we go back to substituting. We have minus 2 ln cosine theta equals ln x. Now we have to take a look at what we've got. We've got theta, and theta was, we got v equals tangent theta, so we got v on 1, and that's v squared plus 1. So we have ln 1 over cosine theta squared equals ln x, and then plus constant somewhere in there. Can't forget that constant. Where did I put that constant? Did I put it here? Yeah, I did, didn't I? Put it on this side. So let's make an adjustment. Plus constant equals. Okay. So this is what I did. Now if we take our exponent, and we end up with 1 over cosine squared theta times e to the c equals x. And we know that cosine squared is u, so that's 1 on u squared equals, we can say cx if we want, or we could leave it this way. We could say c, and u was cosine. Okay, we already gone from u, so I don't want to go back. Okay, so this basically is just a constant. So we see, and we know now that tangent is v over 1 equals tangent theta. So cosine theta is 1 over v squared plus 1, but we got cosine squared, and we got 1 over cosine squared, so 1 over cosine squared theta equals v squared plus 1. And so we have c times v squared plus 1 equals x. And we do a little more algebra. We got v squared plus 1 equals cx, and v is y on x. So now we go back to our initial variables. We got y squared on x squared plus 1 equals cx. And now we are out of room on my sheet, but I don't think we need this stuff here anymore. Why? Huh. It's not working. Why? What's going on here? Did my pen run out of power? I had plugged it in. Boy, what a point for my pencil to run out of power. Let's see if it writes. Okay, let's erase. There we go. Sometimes software just doesn't work for unexplained reasons. Okay, so now give ourselves a little room. Complete our... just lost a sheet. Darn it. Alright. I lost a sheet to a problem. Okay. So, let's bring this up here. We got y squared plus x squared equals... Darn it. I'm going to lose an entire... This was a big problem that I lost, so I'm not going to do that. Okay, so we have cx to the third, y squared equals cx to the third minus x squared equals x squared times c x minus 1, and y equals x square root of cx minus 1. Okay, so that should be the solution. And yeah, there we go. That's it. That's our problem. Let's box it. Let's box it. And sorry about the interruption. Doing things outdoors sometimes has some unexpected consequences, like the occasional breeze. And I didn't put a weight down on my paper, so it blew away. So now, let's look at Another problem which, unfortunately, I got only one piece of because it blew away on me. So let's take a look at this problem, and we'll just play it by ear. So we got dy dx is equal to 4y minus 3x on 2x minus y. So now we got to get this into the form that we're used to. So here, what did I write? This is 4. I'm not paying much attention to what I'm doing. Here's the problem. 4y minus 3x over 2x minus y. So I got the problem right. Written down right, that is. Okay, so we got 4y over 2x minus y minus 3x over 2x minus y. Yeah. Now let's get this into our form. We've got, let's say if we divided everything by, let's see, by y, we got 4 over okay, now we have 2x plus y minus 1. And that's minus 3x on y times 2x on y minus 1. So we've got x on y. And at this point, I'm just going to go with what the convention that I've been using. Instead of using v equals that, I'm going to still work with v equals y on x. And I'm going to say this is 4 on 2 on 1 over v minus 1 minus 3 1 over v on 2 1 over v minus 1, and just do the algebra. So we have, okay, 2 minus v on, let's see, 4 v over 2 minus v minus, now we have 2, 3, 1 over v on 2 minus 1 times v, and so we have 4 v over 2 minus v minus 3 on 2 minus v. And that would be x dv dx plus v. Now we have to bring that v over. So x dv dx equals 4v on 2 minus v minus 3 on 2 minus v minus v, so that is minus v times 2 minus v over 2 minus v. And what does that give us? we have 4v minus 3 minus 2v plus v squared, all on 2 minus v. And that's equal to v squared plus 2v minus 3 on 2 minus v. So now x dv dx. Sun's creeping up on us. Every so often we get a break in the clouds and the sun really beams down on us. And it makes it difficult to see the screen, even though I'm still partially in the shade. Alright, so what do? Let's see if we can factor that numerator. So let's say we got v equals, I'm going to use the quadratic formula to find the factors for the numerators. So we got minus 1 plus or minus 1/2 times, that's 4, minus 4 times minus 3, and that is equal to minus 1 plus or minus 1/2 of 16, and the square root of 16 is 4, so that's going to be plus or minus 2. So let's just streamline it. So we got minus 3 and 1. So we have x minus 1 times x plus, or v, we could say v. Yeah, let's not confuse it. So we have v minus 1 times v plus 3, and that's equal to v squared plus 3v minus v minus 3, and that gives us the numerator. So we can rewrite this. Let's give ourselves some space. Do a little erasure, make sure I got everything. This is equal to x dv dx is equal to v minus 1 times v plus 3, and that's on top of 2 minus v. And there we go. And so we can rewrite our equation as 2 minus v on v minus 1 times v plus 3 dv equals dx on x. And that's our equation. So now we go to another sheet. This is one of the more, starting to get more complex type. Come on. All right, so yes, that sun is creeping on us quickly. So we had 2 minus v dv on v minus 1 times v plus 3 equals dx on x. And so we're going to have a real time of it here. This is going to require us to do, we're going to have to separate this by partial fractions. So we got 2 over 2 dv over v minus 1 on v plus 3 minus v dv on v minus 1 v plus 3, and we're going to say that a on v minus 1 plus b on v plus 3 is equal to 1 over v minus 1. We could say it's 2, probably easier, times v plus 3, multiply across a times v plus 3 plus b times v minus 1 equals 1. And if we say that v equals 1, we have for a equals 1, a equals 1/4. So 1/4 of v plus 3 plus b times v minus 1 equals 1. And if we said that v is 0, then we have 3/4 plus minus b equals 1. So minus b equals 1/4. B is minus 1/4. Does that work? 1/4 over v minus 1 plus or minus 1/4 on v plus 3. And if we multiply across, we've got v on 4 plus 3/4 minus v on 4 plus 1/4, and that gives us 1 on v minus 1 times v plus 3. So we've got that. Let's now erase, give us some working room. Remember our results. That's always a trick. Let's clean the board. And we got 2 times 1/4, so we got 1/2 dv on v minus 1 minus 1/4 times 2 is minus 1/2 dv on v plus 3 minus v on v minus 1 times v plus 3 dv equals dx on x. Now we still have this troublesome v over v minus 1 times v plus 3 term. See if we can break that up into partial fractions. So again, we go a on v minus 1 plus b on v plus 3 equals v on v minus 1 times v plus 3. Now multiplying across, we got a times v plus 3 plus b times v minus 1 equals v. That's the difference. Get rid of these marks. I hate messy boards, but sometimes, when your hand touches it, it makes a mark. Okay, so in this case, let's try v equals 0. V equals 0. So we have 3a. No, let's do it differently. Let's say v equals 1. So let's say v equals 1. We got 4a equals 1. A equals 1/4. That looks familiar. Okay, so 1/4 times v plus 3 equals, or plus, v on v times v minus 1 equals v. All right, so maybe in this case, choosing v equals 0, we've got 3/4 minus b equals 0, so b equals minus 3/4. And let's give that a try. 1/4 v minus 1 minus 3/4 v plus 3. Let's see how that works. We got v 4 plus 3/4 minus 3/4 v minus 3/4 v plus 3/4. That doesn't work. I did something wrong. Okay, gotta be careful when you do these things. Okay, so we have a is 1/4. What if what if what if we had, let's make sure I did this right, v plus 3, v minus 1 equals v. Okay, if we chose v equals 1, we have 4a equals 1, a equals 1/4, so that's correct. If we said v equals 0, I gotta get my pen, v equals 0, so we have 3/4 plus minus 1 minus b equals 0. Minus b equals minus 3/4, and b is 3/4. Okay, that's where I went wrong. So we have 1/4 v minus 1 plus 3/4 v minus 3, v on 4 minus 3/4 plus 3/4 oh, that's plus. Okay. Plus, this is plus 3/4, and that's 3/4 v minus 3/4 all over v minus 1 times v plus 3, and that's v over v minus 1, so we got it. Alright, so in this case we now have our final form. We have 1/2 dv over v minus 1 minus 1/2 dv over v plus 3 minus, okay, we have 1/4 v minus 1, and that's plus 3/4 on v plus 3 dv equals dx on x. Okay, so let's clean up the board a little bit. Let's get rid of this. We got our fractions, and we do a little more algebra. And we got 1/2 minus 1/4. That's minus 2/4. So we got 1/2 dv on v minus 1 minus 1/4 v minus 1 dv minus 1/2 dv on v plus 3 minus 3/4 dv on v plus 3 equals dx on x, and that gives us, this is minus 2/4. Let's see, this is 2/4 minus 1/4, so we got 1/4 1 minus v dv minus, this is 2/4 minus 3/4, that's minus 5/4 dv on v plus 3 equals dx on x, and there we go. We can do our integrating. So we got 1/4 ln v minus 1 minus 5/4 ln of v plus 3 equals ln x plus c. And now we know we got v equals y on x. So we have to go to another sheet. So we have what's the matter with that? 1/4 ln of v plus or minus 1 minus 5/4 ln v plus 3 equals ln x plus c. Was that the right equation? Let's go back and check just to make sure. 1/4 minus 5/4. Okay, that should do it. Okay, that's the equation. All right, so we now have to put these into okay, this is correct. All right, so we have to put these into their power, v minus 1 over to 1/4 minus ln v plus 3 to the 5/4 equals ln x plus c. Now we do a little more logarithmic algebra. We got ln of v minus 1 to the 1/4 over v plus 3 to the 5/4 is equal to ln x plus c. Now we start bringing everything to the using exponentials. We've got then e to that and e to all this, and this is equal to c x. We're going to do that. And this is v minus 1 to the 1/4 over v plus 3 to the 5/4. And if we raise everything to the 4th power, we've got v minus 1 over v plus 3 to the 5th equals cx to the 4th. V minus 1 equals cx to the 4th times v plus 3 to the 5th. And then, again, y over x is v. Let's get rid of this mess I made. And so we got y on x minus 1 equals c x to the 4th times y on x plus 3 to the 5th. You got y minus x equals cx to the 5th. And this is y plus 3x to the 5th on x to the 5th. And we have y equals c y plus 3x to the 5th minus x, or plus x. And or we could just leave it the way it was. We could call it c times y minus x equals y plus 3x to the 5th. And that's the way the book left the answer, so we'll just leave it like that. As you can see, these are becoming a little bit more complicated. Now the next one is truly complicated. And I think it's going to take us a bit of doing. It's going to require a lot of attention. And I think this will be the one that we quit with, all right? It took 3 sheets of paper for me to solve this, although I didn't write economically, but I did have to break it down. Actually, there was another one that was pretty challenging, to be quite honest, because when you start, okay, I'll show you, because we're going to do dummy variables that extend beyond v equals y over x, because we have a problem here. We have, in this one, dy dx is equal to 2y minus x plus 5 over 2x minus y plus, minus 4. Okay, so what do? Because we have these constants, and that makes it problematic, because if I try to factor out a y or divide by y, we're not gonna have a y on x. So what do we do in that situation? Well, we kind of force it. Let's see. Guess it's probably easier just to erase. We know that the constant values pose a problem. So what we do in this case is we choose a variable. We say 2p minus q and 2q minus p. So we're saying here that the numerator is equal to 2p minus q, and that the denominator is equal to 2q minus p. So if we do the math, we solve it like a system of equations. So we can come back, because in this case, we're going to say that p is equal to qv, or p on q is our v. Okay, and then we have dp dq is equal to q dv dq plus v. So that's how we're going to approach this problem. So now we have to choose the values for p and q. So if the denominator or the numerator is 2y minus x plus 5 is equal to 2p minus q, then to isolate the y variable, we multiply, or x variable, we multiply everything, or the denominator, by 2. So we got 4x minus 2y minus 8 is equal to 4q minus 2p. Just multiplied everything by 2. Now I add these together. The y's cancel out, and I've got 3x minus 3 equals, and the p's cancel out, and we have 3q. And this means it's all divisible by 3, so we got x minus 1 equals q, and x equals q plus 1. Those jet skis are noisy suckers. Now we have to solve for the y variable. Okay, so in order to get the y variable, we multiply the numerator by 2, so we got 4y minus 2x plus 10 is equal to 4p minus 2q, and then denominator is 2x minus y minus 4 equals 2q minus p. And again, we just add the two, and our x's cancel. We've got 3y plus 6 equals, the q's cancel, and we got 3p. So this is y plus 2 equals p, and y equals p minus 2. And we notice that dx is dq, and dy is dp. So dy dx is equal to dp dq. So dy dx is equal to dp dq, which is equal to q dv on dq plus v. And now we're set, because we have the equation q dp dq plus v is equal to 2p minus q on 2q minus p. And if we divide the numerator and the denominator by q, we have 2p on q minus 1 over 2 minus p on q. And that then is equal to 2v minus 1 on 2 minus v. So, there we go. We have the differential equation, q dp dq plus v equals 2v minus 1 over 2 minus v. And we need a new sheet. You can see how this is involved. Okay, so we have q dp dq plus v equals, what was that again? What'd we say that was? 2v minus 1 and 2 minus v. 2v minus 1, so we have 2v minus 1 on 2 minus v. Just make sure I got it. Okay, everything is good. Alright, so now if we separate this, we got 2v on 2 minus v. Well, let's not do that right now. Let's jump in a bit too far in advance. So we got q dp dq equals 2v minus 1 on 2 minus v times 2 minus v on 2 minus v. And we're in the full sun here. Oh, and it doesn't look like we're going to have a cloud in a while. Okay, so we got 2v minus 1 minus 2v plus v squared on 2 minus v. That's equal to v squared minus 1 on 2 minus v. So, q dp dq. Now we bring things over. What did I do? I did this incorrectly. This is dv dq. Sorry, guys. Made an error. dv, dv, dv. Did I do that on the other one? Yes, I did. That's wrong. This is dv, dv. But I did have that right over here. So that's our differential equation. So you got to be very careful all the way through. Boy, I wish I had some shade right now. Bring it over to somewhere. What happens is these screens get hot. Okay, so here we go. We got 2 minus v on v squared minus 1 dv equals dq on q. Yeah, that's what we got. And so we got 2 on v plus 1 times v minus 1 minus v on v plus 1 v minus 1 dv equals dq on q. And as you notice, we've got the same situation as in the previous problem, where we have to use partial fractions. And we got a times v minus 1 plus b times v plus 1 equals 1. And we go through the whole business solving for a and b. So if v is 1, we got 2b equals 1, b equals 1/2. And so if b, let's say v is minus 1, we got minus 2a equals 1, a equals minus 1/2. And let's see, minus 1/2 over v plus 1 plus 1/2 over v minus 1, and that's equal to minus 1/2 v plus 1/2 plus v on 2 plus 1/2, and that works. So we got that to work. So we got, and that's multiplied by 2, so we got minus 1 over v plus 1 and plus 1, or dv, and dv over v minus 1 minus v on v plus 1 times v minus 1 dv equals dq on q. And we do the same thing for the second term, the second v term. I have a funny feeling that when I go over that thing over there, it stops working. There we go. There we go. Erase, erase, erase. Okay, so now we want to find the v term. So we got, again, we're going to say A is, well, let's shorten it a little bit so we don't have to go through every single detail. So we got A times v minus 1 plus B times v plus 1 equals v in this case. And so if we say v equals 1, we got 2b equals 1. b equals 1/2. Now, a v minus 1 plus 1/2 times v plus 1 equals v. Let's say v equals 0. Minus a plus 1/2 equals 0. A minus a equals minus 1/2. A equals 1/2. So now we've got minus dv on v plus 1 plus dv on v minus 1 minus, we got 1/2 on v plus 1 plus 1/2 of v minus 1 dv equals dq on q. Before we go any further and make any mistakes, let's just confirm our partial fraction. So we got b is 1/2 and a is 1/2, so we got 1/2 over v plus 1 and 1/2 v minus 1 is equal to v on 2 plus 1/2 or minus 1/2, sorry, minus 1/2 plus v on 2 plus 1/2 on v plus 1, v minus 1, and that is v on v plus 1 times v minus 1, and we did it. Okay, so just double checking. It's always a good idea to double check because you can always very easily screw up with a sign. So now we have our differential equation. Okay, so let's get things right. And this is our differential. And if we do the algebra, we have let's I think this thing is starting to overheat because of the sun. I'm going to take it inside so that we don't lose this. It's just about ready to overheat on me. It's amazing how fast this happens in the sun. Let me get my sheets. And let's move into the sun. Into the house. It is beautiful out here, but the sun is hot. It's the 4th of July, and the screen absorbs heat, and these things are notoriously bad in the sun. And we're almost done with this final problem. And I'm going to keep the narration down to a minimum. Just so that we can solve this problem. But you'll see right at this point it's a matter of rote. Okay, so let's see what we have. It was then the 23-year-old captain first heard from court. Adolf articulated the rage Wilhelm felt against the politicians who had let down the troops and created the mess that Germany was in. In July 1921, Hitler was elected leader. We got a documentary going on in the background, so let's. If you hear things, it's because of a documentary on the History Channel. Okay. Now let's see. What was our equation again? Minus dv plus dv minus minus. Okay. All right. So let's get back. Minus dv and v. Despite a case, winner of Germany's highest award for valor, the Fall of Merit, Blue Max, Goering was put in over Wilhelm's head. It was the beginning of a feud which was to have fatal consequences. At the same time, a smaller group of SA men was hived off to be a personal bodyguard for Hitler. It was the beginning of the essence. Eventually, it became the most fearsome and sinister organization in the Nazi state. It was the beginning of a feud which was to have fatal consequences. At the same time, a smaller group of SA men was hived off to be a personal bodyguard for Hitler. It was the beginning of the essence, which was eventually to become the most fearsome and sinister organization in the Nazi state. As the SA grew in numbers to become a paramilitary force that would challenge even the authority of the regular German army, the SS broke away. All right, so here we go. We solved this equation. We can now go back to our original. Remember, V was P on Q. And so, let's look at this. We got then 1. In 1923, Wilhelm took part in Hitler's Munich Putsch and was imprisoned in his collapse. And the eventual fate of Hans Göring. In 1923, Wilhelm took part in Hitler's Munich Putsch and was imprisoned in his collapse. Or we could put the C over here if we want. But let's just do it this way for now. So we got p minus 1 and half. Now let's do it this way. C plus and there.
The clash culminated in 1925 with Hitler sacking Rome. He thanked him wholeheartedly for his early support, but he could not tolerate the revolutionary and semi-independent system. Disillusioned, Rome sailed to Bolivia to work as a military advisor. In the meantime, Hitler gave command of the SA to an ex-Freikorps commander, Captain Pfeffer von Salem.
There we go. And now we put in our p. We got e to the c. P on q minus 1. Half achieved his aim of winning electoral support and stood on the verge of being in power with government. This was largely due to Germany's plunge into deep recession after the Wall Street crash of 1929. Thousands of unemployed and frustrated young men joined the ranks of the SA branch. It soon became a massive force which rivaled the power of the small, widespread army. In its ranks were many left-wingers who believed strongly in the socialist aspect of the Nazi Party. One of these was Walter Schmerz, leader of the SA in Berlin. In September 1930, he led a mutiny accusing Hitler of betraying the Nazis' revolutionary cause. This uprising was quelled with the help of the SS and the police. It was a dire warning. He took direct command of the SA and sent a message to Rome in Bolivia, asking him to come back as his deputy and get a grip. It was a tremendous camp. And
let's... He already sacked Rome once because he wanted to turn the SA into an independent band of revolutionary warriors. But now Hitler had the choice. The SA was getting out of control, and he knew Rome was a ruthless disciplinarian. Events had moved on since Rome had last seen him. But Europe had grown in stature as a national politician. Surely that must be...
Now we go back. Whoops. We go back and look at our q was x minus 1. So let's...
It was exactly what Hitler did. But this time the SA was not the only Nazi force in
x minus 1. So
call on the SS, and it was only technically to square up to the troublesome SA.
q equals x minus 1.
The SS's ruthless leader, had marched over Germany
And p was y plus 2. P equals y plus 2. So with that, we put those back in. So x minus 1 minus y minus 2 is equal to c y plus 2 plus x minus 1, and we have x minus y minus 3 equals c y plus x plus 1.
He organized the
And that's it.
and greatly increased its membership. Some
You can see how tremendously involved that problem was.
1932, he commanded over 500,000 branches.
And there, we're done with this video.
The potential for
And actually done with our methods for first order
including the regular arm.
differential equations.
The essay was now 5 times
And I'm going to do it, the next video is just going to be some miscellaneous problems, and then we'll do applications and move on to second order differentials. So with that, we pretty much ended the first segment of differential equations.